Shiva. I'm from King's College London. I'm a PhD student under the supervision of Professor Kaspar Altufer. And today I'll be talking about tendon stiffening for a pneumatically actuated manipulator, which was developed as part of the EU project StiffLab. The project was led by Professor Altufer, and it was done in collaboration with SSSA and UCL and some other partners. So we all know that there is an emerging trend towards using continuum manipulators due to their extended dexterity compared to rigid manipulators. However, we know that the inherent flexible structure poses new challenges, namely in order to cope with the external forces, so we have to come up with some strategies to adjust the stiffness. Taking inspiration from biology, the StiffLab manipulator was designed, which currently is based on the idea of having silicone chambers which are braided, multiplied, cast into a silicone body, and capped on bottom and top with air inlet pipes. So in the case of air pressurization, each chamber tends to elongate independently, which would eventually give 3 degrees of freedom in bending and elongation. In order to carry out our experiment, the StiffLab manipulator was enhanced further to incorporate 3 tendon stiffening wires, which were placed at 120 degrees orientation. So we had a system which had pressure adjustment for actuation and tendon stiffening. We carried out our experiments using a linear guide rail to apply 1 centimeter lateral displacement at the tip, and we measured the force using an ATI 917 force sensor, and we carried out our experiment in different configurations. Results showed that tendon stiffening increased the load-bearing capacity in different configurations by different amounts. So, for example, we saw an increase of 24% in this case, an increase of nearly 30% in this situation, and around 70% and nearly 90% in this configuration.